Today we start our new chapter, that is noble gas chemistry. Guys, I will try my best. This video will be very informative for you. So guys, please watch it till the end. So let's start with the basic concept of noble gases. Introduction. There are 6 noble gases element present in periodic table. They are namely helium, neon, argon, krypton, xenon and radon. Generally, the noble gases are colorless, odorless, tasteless and non-flammable gas. Non-flammable gas. When we see these noble gases, all the noble gases are present in atmosphere except radon, because radon is artificially synthesized radioactive element. Remaining 5 noble gases are present in atmosphere. Noble gases have been labeled zero group because decades after their discovery, it was believed that they could not bonded to other atoms, means they could not combine with other element. So that's why it's given the name zero, means it's having zero valency. When the members of groups were discovered and identified, they were thought to be extremely rare as well as chemically inert, and therefore were called as the rare gases or inert gases. Next point, position of noble gases. Position of noble gases. I draw here a rough sketch of noble gases. This is the sketch of long form of periodic table. In long form of periodic table, S block is placed at extremely left hand side of the periodic table. Then P block is placed at extremely right hand side of the periodic table. D block is placed in between S and P block, and at the bottom F block is present. This shaded area shows us the position of noble gas in periodic table. When we see the history of periodic table, then we will see that the Mendeleev had not placed any space for noble gases because noble gases did not exist at that time. After that, in 1894, Sir William Ramsay he will discover the element and introduce a new group of periodic table on the basis of highly stable NH2-NP6 electronic configuration. NH2-NP6 electronic configuration. We already discussed about noble gases gives us the zero group element. Noble gases are also called as the zero group element because it's having zero valency or no valency. Valency means combining capacity of element, and noble gases could not combine with other element. So that's why it is called as the zero group elements. Then next point is occurrence of noble gases. Occurrence of noble gases. Noble gases are a rare element because they does not abundantly occur in nature. So let's see the percentage of noble gases in atmosphere. We all know that all the gases are present in atmosphere except radon, because radon is artificially synthesized radioactive element. It is synthesized by disintegration of radium element. So let's see the percent of noble gas in atmosphere. Helium is present is near about 0.0005%. Then neon, percent of neon is 0.0015%. Then percent of argon is 0.936%. And krypton is 0.00011%. And xenon is a very rare element because its percentage is very less, that is 0.00001%. And electronic configuration of noble gases. Electronic configuration of noble gases. When we see the electronic configuration of noble gases, we will see that the electronic configuration of helium is 1s2. Electronic configuration of neon is 2s2, 2p6. Argon 3s2, 3p6. Krypton 4s2, 4p6. Xenon 5s2, 5p6. And last one, radon is 6s2, 6p6. We will see that all the noble gases having 2 electron in s orbit and 6 electron in p orbit. So that's why general outermost electronic configuration of noble gases is ns2 np6. This is the general outermost electronic configuration. Except helium, because helium having only 2 electrons that are present in s orbit. Next point, compounds of inert gases. Compounds of inert gases or noble gases. Inert gases or noble gases. Noble gases are isolated and discovered because of lack of reactivity. For a long time, it was thought that they were chemically inert. There were only evidence for the formation of compound. Let's see it in two types. Number one is the molecular ion. Molecular ions formed under excited condition. In which we see the example of helium. We know that the atomic number of helium is 2, and therefore the electronic configuration of helium in ground state is 1s2. In ground state, helium is very inactive because the outermost electronic configuration of helium is very stable, and therefore it requires high amount of energy to excite one electron from higher energy level. The electronic configuration of helium in ground state is 1s2. 1s2. By passing electrical discharge in ground state of helium, then excitation of electron takes place from ground state to higher energy level. Therefore, electronic configuration of helium in excited state is 1s1 and 2s1. The excited state of helium is active and form different compound. For example, He2 plus 2, HEH plus or HEH plus 2. The next one is by physical trapping. By physical trapping. It is also called as the clathrates. Guys, this is very important point because many times the question is asked on this point. So that's why do not skip it. So first of all we see the clathrates. The word clathrate. Clathrate is a Latin word means enclosed. And clathrate is also called as the cage-like compounds. In simple way, we can say that we capture noble gas. I draw here noble gas. Okay, we capture noble gases and lock them in a cage. I draw here a cage. Okay, so this is called as the clathrates. Noble gases form a number of compounds in which these gases are trapped within the cavity of crystal lattice of certain organic or inorganic compound. Such compounds are called as the clathrates. I draw here a rough sketch. This noble gases. The noble gases means the guest molecule, and this cavity means the host molecule. Means we can say noble gases is guest and cavity is host. When we see the history of clathrates before the independence in 1945, in 1945, the scientist H.M. Powell analyzed the crystal structure of these compounds and named them clathrates. And he explained the clathrates compound with suitable example. Number one is hydride clathrate. When water is allowed to freeze in the presence of noble gases such as argon, krypton, xenon under pressure, then these noble gases are trapped within the cavity of ice cube, within the cavity of crystal of ice, and form hydride clathrates. In hydride clathrate, these noble gases and water molecule were held together by hydrogen bonding. Example of hydride clathrate is, for example, argon 6H2O, xenon 6H2O. This is the example of hydride clathrate. Next one is the phenol clathrates. When phenol is allowed to crystallize in the presence of noble gases such as argon, krypton, and xenon under pressure, these gases are trapped within the cavity of crystal of quinone, and these are called as the quinone clathrates. And in quinone clathrates, the quinone and noble gases hold together by hydrogen bonding. It's held together by hydrogen bonding. For example, I draw here a quinone clathrate compounds. In both example, water and quinone both are host molecule, and the noble gases which are trapped in the host molecule are called the guest molecule. Means, in short, noble gases is guest and this quinone or water is the host molecule. So next point is the condition of clathrate. Let's see the condition of clathrates compound. The very important and essential condition for the formation of clathrate compound is that the host molecule should have the appropriate size cavity in which the noble gases can be easily fit. For example, this type of noble gases can be easily fit in this type of cavity. So, if we have a noble gases of this size, then this size noble gas cannot be fit in such a type of cavity. So, it's need to have a appropriate size of cavity. This is most important condition for formation of clathrate compound. Okay. Applications of clathrate compound. Applications of clathrates compound. First application is clathrate compound is used to store noble gases. Then it is used for separation of noble gases. Then it is also used for separation of hydrocarbons. The next one is clathrates compounds are used to desalinization of seawater. Okay. Then last one is it is used for preparation of straight chain paraffin. These are the application of clathrates compound. First is clathrates compound are used to store noble gases. Next one, it is used for the separation of noble gases. It is also used for the separation of hydrocarbons. Then it is used for the desalinization of the seawater, and it is used for the preparation of straight chain paraffin. This is the application of clathrates compound. Next point, why are noble gases are unreactive? Because noble gases having highly stable electronic configuration Therefore, it's having high ionization energy. Their electron affinity is almost zero. So that's why the noble gases are unreactive. Due to the highly stable electronic configuration, it's having high ionization energy. Ionization energy, minimum energy is required to remove most loosely bound electron from isolated gaseous neutral atom. For example, I draw here a atom. This is nucleus, this outermost shell. The minimum energy is required to remove most loosely bound electron. That is called as the ionization energy. And electron affinity means amount of energy is required to add one more electron in outermost shell, and due to the highly stable electronic configuration cannot able to add one more electron. So that's why the electron affinity of noble gases is almost zero. Noble gases cannot take part in any chemical reaction, they cannot give or take any electron, so that's why we call noble gases are very unreactive. Now we are stop here, and the remaining portion we'll discuss in next part. So important thing is, do not forget to like, share and subscribe.